Hi everybody, so we are going to graduate to like elementary level proofs, let's call it, and we are going to use givens. So I'm Miss Osier
and Miss Perrier,
and we are going to get started. So what you are seeing in front of you, that you can have lots of given in proofs. We're just breaking it down to very common givens that you'll see in the proofs that we'll do. So the first is that T is the midpoint of QS. Notice I didn't tell you anything was congruent. You have to logically deduce that if T is in the middle of QS, that segment QT is congruent to segment TS. So that would be the statement part in your two-column proof. The reason would be, well, it came from the fact that it's basically the definition of the midpoint, but you're going to kind of write it out. So you're going to say a midpoint divides a segment into two congruent parts. You can say other correct things, but that's the one that if you were just wanting to memorize, we would suggest this one.
Next, we have a segment bisector here, and remember the word segment here, not angle, segment. So JN bisects ML, so that means that when our statement, we're going to write MK is congruent to KL, and the reason because a segment bisector cuts a segment into two congruent segments. Again, that is just the reason that you were going to kind of have to memorize when we do these types of things.
Yep. You always have to justify it. It's not ever just because or duh, it's a bisector. You have to give the specific reason why you know. Now, another bisector you will see is an angle bisector. This means that you're cutting angles in half. So instead of doing the dash marks, you're going to be doing the arc marks. So you first find the angles, Z, X, Y, and then you make your arcs. That half and that half are the same. I label that appropriately with its full name because the vertex X, there's multiple angles there. So I give the angle YXM and the angle MXZ is congruent. The reason is going to look just like the other one, but the word angle is going to be there. So an angle bisector cuts an angle into two congruent angles. It's overkill a little bit. We would accept a bisector cut something into two congruent parts, but for now, make sure you're really focused on that angle part.
Next one, we got parallel lines. So PR is parallel to QS. Those double vertical lines mean parallel here. So there's a lot of things that we can get from parallel lines, but this is the main one we want to stress, is these alternate interior angles that are labeled on the screen. RPS angle is congruent to angle QSP, and the reason because those are alternate interior angles. They are congruent when lines are parallel. That's just like a definition that we learned that you just need to continue to remember.
And one of the biggest mistakes we see students make is they will read this and then they'll say that those two segments are congruent. Parallel lines has nothing to do with congruency. I could have a little itty bitty line and it could be parallel to the most gigantic line you've ever seen. Parallelism does not mean congruence or equal. Just so you know, alternate exterior angles and corresponding angles also show up with parallel lines. In the proofs we do, they show up less often, so we really focus on the alternate interior, but we will expose you to some where you'll see those as well.
For this one, we have perpendicular lines now. So we have XM is perpendicular to YZ, and whenever you guys see perpendicular lines, you need to know that they make right angles. That's just something we need to know by now. So our statement here would be angle YMX is congruent to angle XMZ, and the reason because perpendicular lines make congruent right angles. Again, we've stressed that. This is something that you just need to be knowing by now.
So now that is if you want the angles to be congruent. You can also have the word perpendicular show up and just want to tell me that you have right angles. This again would be a strategy. You would have to, as we practice, we'll learn more about which one we want to use. So the other statement when you have the word perpendicular would be that those angles are right angles, and you're not saying that they're congruent because we don't care if they're equal. We need them to be right angles for whatever reason. Remember, if I'm going to say 1, 2, 3, and 4, I have to draw 1, 2, 3, and 4 into my picture, which I just did. This given wasn't just a perpendicular line, it also has the word bisector. So there's a second statement I can get out of this. This given is a twofer because there's two vocabulary words in it. So TE is congruent to EU is the other one, and that comes from the bisector. A bisector cuts a segment into two congruent segments. So really it's just two that you've already used, but they're in together, and we took this opportunity to show you the other statement that perpendicular lines can give you.
So for this one, we have our example, we have a given, we have a proof. So now we're going to see which method or criteria fits this problem. So for this one, we have the given XM bisects angle YXZ. So for this one, we'll have the two arc marks there, so we know that's an A. And then we got XY is congruent to XZ, so then we know that's a side. And then we want to prove that why these two triangles are congruent. So again, we can see that these two triangles share a side, so we know that that's the reflexive property. So for this one, we have SAS, S-A-S, because we have a side, we have an angle, and we have another side.
For the next example, R is the midpoint of segment PT. So I stop. I know that if R is in the middle of PT, that I have two congruent segments, so I mark them. And then the other parts are just given to me like in the other proofs we did. So angle P is congruent to angle T. It's already labeled. And then the two angles at R, PRQ and TRS, are also congruent. So now I know that this is angle, side, angle. And again, we've already practiced that, so we're hoping that the side, angle criteria is a little bit easier for you to spot.
So again, for this one, we have AC bisects the angle BAD again, so then we know those are two congruent angles. And then we have BD is congruent to BD, so those are other two angles. And then lastly, we have the reflexive property again, so that's a side. So what method this could be is angle side again.
Now that's one of those ones you want to be careful and make sure you cover, because it kind of looks like angle side angle because of that shared side. So as a suggestion, cover one of the triangles, and then you should realize that the side, although it's in between the two angles at the bottom, they're not in the same triangle. Number whatever, 2 again, I guess. In the diagram of quadrilateral ABCD, we have the parallel lines. So again, I'm going to look for alternate interior angles first because they're the most common. If you look for the letter Z, that's the surefire way to find them. So there's a pair of alternate interior angles. And then I'm also told the angle ABC is congruent to angle CDA, so I give those a double arc. And I'm out of givens. They are bringing my attention to AC, and that's my reflexive property. So this would be angle side again.
So for this one, we got HK bisects IL, so this is a segment here, so these are going to be two congruent segments. Then we got angle H is congruent to angle K, so that's our angle here. And then for this one, we can see that we have vertical angles, so again, we'll put the double arcs there. So for this one, again, we'll have angle, side.
Don't ever be worried if you get the same criteria a lot. Sometimes it's just coincidence that they're all ending up to be angle, side. Like what we just did, 3 that were that. Don't ever get worried about that kind of stuff. Which method can prove the triangle is congruent? We have LJ bisecting angle IJK, so that's getting the arcs. Angle ILJ is congruent to angle JLK, some more arcs, and then we have the reflexive property again, which you are all stars at spotting at this point, and then we have angle, side, angle.
Okay, so for this one, we're actually going to write out the 2-column proof here. So first, what we want you to do is write your givens, and again, you can write them together, or you can write them separately. That is all up to you. So we have SV is congruent to TU, so we got a side, and then we got that SV is parallel to TU, so that's also our given. So when we see parallel, we can also think of alternate interior angles, so that's what we're going to spot here. So we have angle 1 is congruent to angle 2 because we labeled them, and because of the alternate interiors are congruent when lines are parallel. And then finally, we can use the vertical angles that we have for these two triangles. And again, we're going to label those 3 and 4. Again, make sure you label them. That is super duper important. And that's because vertical angles are congruent. So lastly, we have our 3 criteria that we need, so we can say that they are congruent by angle, side.
A suggestion as you're keeping yourself organized as you're writing through your proof, like here this gave us a side in our angle side. We had 2 sides congruent. Here we had an angle, and here we had an angle. Once you have the 3 things you need, that's how you know you can get to that last step. Just as a suggestion to help you, because sometimes you're like, am I done? If you have all 3 parts, yes, you are done. So we're going to do one more. Which method are we going to use? And then let's go ahead and prove it. So Q is the midpoint of PR. Well, that tells me nothing at the moment in my proof. So I have to logically deduce that those 2 sides are congruent. So PQ is congruent to QR. And then I'm just rewriting the reason that we put in the chart for you. My other givens were nice ones. I say nice ones because they're telling me sides. They're telling me other stuff that I need. So I don't need to put another statement after it because it's giving me one of those sides. And then I have the triangles congruent because of side, side, side. So we're going to practice those. Be patient with yourself. And that's it for this video. We'll see you in class.